It's time to go over the free response questions. I'm going to be doing this in two parts. I'm going to spend some time going over, in the first part, pen tool here, I'm going to be going over free response 1, 2, and in the second video, we're going to go over free response 3. Again, this is so that I can move a little slower and be more clear. The first free response problem, it says, consider the reaction represented below, which is spontaneous at 298 Kelvin. Immediately, we're going to know that delta G is negative if it's spontaneous. Okay. What other information have they given us before we start this problem? We know that delta H is negative, which means it's exothermic. For the reaction, indicate whether the standard entropy change, delta S, at 298 Kelvin is positive, negative, or 0. Justify your answer. Let's be as clear and concise. Let's first talk about delta S. Go up to the reaction. We have 3 moles on the left, and we have 2 moles on the right, and we also go from gases to solids and liquids. It's getting cleaner. Delta S is going to be less than 0 or negative. Second question. Justify your answer. Well, it seems like we already did justify our answer, but let's be a little more clear. Gases are going to solids and liquids, which are more ordered, and reaction decreases number of moles. 3 reactants goes to 2 products. 2 reasons. Really clear question, straightforward answer. I bet they would accept what I wrote here for delta S as full credit. If you know a lot about this topic, doesn't hurt to write about it, however. B, which factor, the enthalpy or the entropy, delta S, provides the principal driving force for the spontaneity? Blah, 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 blah. Let's think about this. They basically are asking what makes it spontaneous. So, we are going to refer back to the equation for delta G, delta H minus T, delta S. We know that delta H is negative. We know that this is a minus, and we know that delta S is negative. I've told you guys to make this a positive and make this a positive to make it easier to look at. They've locked the temperature here at 298, so we are not manipulating temperature. That's going to be out of the picture. So they want to know what makes it spontaneous. Well, if we can't change temperature, and delta H here is negative, at a high delta H, delta G is going to be less than 0. Okay, so we also know that delta S is a low value. So if delta S is low, the reaction will be spontaneous. In this case, a good enough answer is to say that at a high delta H, delta G will be less than 0. So they basically are just asking you for which factor. So delta H determines the spontaneity. It's kind of a tricky question. I don't know if I understand this that well, actually. So make a little star by this, and we can talk about that in class some more. Oops. Sorry about that. Okay. It's asking you now to discuss how temperature can affect the spontaneity of this reaction. Well, you're used to doing this. Again, delta G equals delta H minus T delta S. We know that delta H is negative. We know that's a negative. This was a negative. Made that positive. And let's look at that. At T equals 0, delta G is less than 0. Remember, temperature can be no lower than 0 in Kelvin. At T equals, let's say, affinity, delta G is going to be greater than 0, meaning when temperature is low here, this side is going to win. And when temperature is high here, this side is going to win. So, at low temperature, it's spontaneous. At high temperature, it's non-spontaneous. Perfect answer. You could write it that way if you wish, or you could write out a paragraph to discuss this. I'm going to try and make our way through free response 2 here in this video clip. Some reactions that are predicted by delta G to be spontaneous at room temperature, but they do not proceed at a measurable rate. Account for this apparent contradiction. This is a simple question. I'm going to give you an example. So you can say, for example, all right, at 2 degrees Celsius, water melts spontaneously. Okay, because the melting point is 0 degrees Celsius. However, at 20 degrees Celsius, water also melts, but at a faster rate. Okay, so I want you thinking about this. I'm going to draw a little chart to do this. At 0 degrees Celsius, okay, water or ice melts spontaneously, but it's slow. Okay. And at 20 degrees Celsius, ice melts. That's also spontaneous. I'm sorry, this was at 2 degrees Celsius. Spontaneously, but fast. So notice here, in both cases it's spontaneous, or delta G is less than 0. However, in one case it's slow, and in one case it's fast. This definitely is a good example of this contradiction. Spontaneous has to do with whether it happens. It has nothing to do with how fast it happened. Go to multiple choice number 10. This topic was also discussed there as well. Alright, I'm going to come back to this last free response problem in the next video. Take care.